that upper limit, x1. Oh, okay. Mag-record ako, hindi ko na-record yung kanina. So, i-evaluate mo lang siya up to that upper limit. And now, if and yung overall cumulative probability across all the range of outcomes or all the values of x-axis. Kung kunyari 0 to 15, then from 0 to 15, yung cumulative probability doon, it's 1. Similarly, kapag generally, negative infinity to positive infinity, the cumulative probability, the big F, general big F of x is equal to 1. But now, if we introduce normal distribution, so ito yung normal distribution, ito yung ideal na in most empirical data sets na nag-gather, ito yung applicable. So we know na ganito yung ideal na shape niya, naka-center dun sa gitna and symmetrical. And for this normal distribution, masisimplify natin yung pagkuha natin. So again, of course, it is again integral from the limits, yung probability. Pero masisimplify natin yung pagkuha natin from table. Meron tayong, I hope, tuningnan nyo na yung sa Appendix A, yung table, nasan yung table? Ito. Cumulative normal probability table. So yung x values natin, nung random variable, ni-transform natin into z values. Kasi itong z values na ito na yung pwede nating, kapag meron tayo, makukuha natin from table yung phi, which is now the cumulative probability at that z value. So, cumulative na siya. The big F kanina naging phi. Phi of z. And then, pwede rin gamitin pang approximate. We said, itong normal distribution sa mga, or continuous distribution sa mga na normally distributed sa mga discrete probabilities such as the binomial distribution and binomial distribution. Again, yung binomial distribution, ito yung pair of outcomes lang palagi yung pwede. So, yung results nila, so say tail or success, the tail and head nung coin, for example. So, in that sense, gagamitin mo pa rin yung sa for normal distribution. Pero yung ano yung pwede mong makuhang ma-solve from your binomial distribution data. Yung mean, it still follows na mean galing sa binomial distribution is equal to NP. And yung sigma mo na or your standard deviation of your sample or this is N naman. So of your population, sigma is NP times 1 minus P. So i-recall nyo lang ulit yun. I hope you did already when you went through this one. So then you can apply your normal distribution. So dito sa examples, ginamit yung from table, yung cumulative probability distribution sa pag-solve. So it greatly simplifies the calculation of the probabilities. So, mas mabilis mahanap yung probability distribution ng population mo. Or kapag nag-sample out ka nung samples na nakuha mo dun sa population. And then yung sa exponential distribution natin, so iba lang yung probability density function niya. Lambda times E. E here is 2.73 or the base of your logarithmic ln. E. So negative lambda to the negative lambda x. So yun lang yung nagbago sa continuous sa normal distribution sa continuous distribution. Okay. Term to get the probability, you still integrate, but iba na yung f of x mo, right? So here, you recall e to the something. So e to the u, let u kung ano yung nandun sa naka-raise. So para ma-simplify mo, para yung dx mo, i-express mo rin in terms of du. So e to the u du times some constant, mabilis mo na siyang ma-evaluate. So meron naman tayong example doon na inisa-isa. Okay, for this one, e to the negative lambda x. So negative lambda x, that is your u. So ano ang du mo? So yung constant negative lambda dx. And so pinalitan mo na yon ng u, e to the u. And then yung dx mo, negative lambda dx. And then you evaluate it from 0 to x1. So since negative yun, kapag 0, so the second term will be, yung para sa 0, it will become 1 kasi e to the 0 is 1. And it's now positive kasi second term siya kanina. And your first term is negative. Negative e to the negative lambda x1. Okay, so we are just recalling. So this is the mean now. And this will be your variance of your distribution. So similar naman yung analysis, nag-iba lang talaga yung f of x. And you can still analyze it that way. Okay. So we can spend time mamaya if you have some questions, pero I will now go to our next topic. Pwede nating bagalan. Konti lang ang nilagay ko dito. Okay. So now, if from a certain population, kumuha ka ng samples mo doon, and then your new samples, the set of your samples now can have its own distribution. So originally, meron kang population, doon ka kumuha. Meron siyang sariling mean, population mean, meron siyang sariling standard deviation. Pero nung nag-sample na ako, kunyari nag-sample ako ng tag-2, tag-3, dun sa mga lahat ng nandun sa population. Tapos yung possibilities ngayon dun sa pag-sample ko, lahat ng yun, meron siyang sariling mean, meron siyang sariling standard deviation or variance. So in sampling, note that in our recall, our statistical inference, we use the characteristics of the sample to approximate the characteristics of your population. And so, if you have a sample mean x bar, and dapat maayos talaga yung pagka-sample mo such that it could be a good estimate of your mu or the sample or the population mean, the entire population. And of course, the S squared, the variance of your sample, can also approximate the population variance sigma square. So dito sa mga distributions natin, naka-sigma na tayo, right? Because we are talking about the whole population. Yung mga sa continuous distributions natin. So, ang catch doon, the sample must truly represent the population from which it came from. So, the sample must be random. Ibig sabihin, may equal probability na makuha bawat isa doon sa sample. Hindi siya biased. Kasi kung biased, parang, ay gusto ko lang yung nandito sa gilid. Ay gusto ko yung nandun sa gitna, yung malalaki. No, when you do the random sampling, may means ka, nakadesign ka ng means ng pag-sample mo na may equal probability makuha yung bawat isa. Walang bias. And kung meron kang interfering factors dun sa system mo, identified mo naman siya to minimize yung epekto nun dun sa pag-sample mo, then you should be randomizing ang pagkuha mo from magkakaibang treatment. Say, yung sa distillation natin, magkakaiba yung temperature doon. So yung pagkuha mo doon sa lahat ng parts na yun, dapat randomized din. May means na randomize siya. And even yung order ng pagkuha mo doon sa magkakaibang treatments. So yung iniba-iba mo yung nag-gather ka, for example, ng data na iniba-iba mo yung temperature doon sa distillation natin, doon sa reboil temperature, distillate concentration, yun yung mga tinignan natin doon, right? And so, yung pagkuha mo doon, sa bawat isang doon, and sa lahat ng yun dapat randomize. And when we say randomize, ano ba yung mga pwedeng techniques para tunay na random? So, merong mga random numbers. So, ipakita ko yung example ng pwedeng mapagkuhanan. Pwede kang mag-program and then you produce, ayun, tab. Okay, ito siguro. Okay, ito. Ito, nakikita na itong random number. So, may mga nakikitang ganito, tables. So, kung naka-code ka doon, then yung corresponding coding mo, yun, pwede kang mag-refer sa mga to kung ano yung isa-sample out mo doon. And kung magaling ka nang mag-program, so pwede ka lang mag-code to produce random numbers, which is not our scope here. Drawing lots. So it's random. Okay. So nasanay tayo so far na isa yung random variable x natin. Now it also occurs that sometimes we have to combine independent variables. And so for example, meron kang linear combination W. It's a function of x and y independent variables. So linear combination, so it's plus. And it is possible that they are multiplied by certain constants or ilang beses sila nandoon sa system. Ilang x. Okay, ilang y. So, if you evaluate now the mean, of course, it's also a function of the means, individual means, nung dalawang pinaghalo mong variables. So, yung mean ng variable x mo is x bar, And yung mean ng variable y mo is y bar. And the constants here are carried over as well. And similarly, yung variance, additive din siya. So kung ang variance ng x mo ngayon, kung isa lang muna, for example, x variable, yung variance niya is x, yung variance niya is, for example, sigma square x. That's the variance of your x variable. Pero, you know that it's a times. So yung actual na variance na nung ax mo is now equal to a square times the variance. Okay, the variance is in square, right? Okay, so now na-square din yung iyong some constant associated to your random variable x. So similarly, kung dalawang variables ito, edi plus second term. The variance of the combined variable w will be a function of the two variances and then multiplied by their constants, square. Okay. So ito yon yung for two independent variables x and y. So yung variance ng combined variable mo now comes from two components, from x and then from the y. And if it's w mo is x plus y, yun nga siya. So it is from two components, x and y. And what if one yung ano mo lang, one yung a and b mo, and then it could just be simplified to this equation 2. What if you have a new combined variable w, pero it comes from x, meron siyang x components ngayon coming from different distributions. Ibig sabihin itong first term ko, sub 1, yung second term ko, sub 2, up to the nth one, galing sila sa iba't ibang populations. And then pinag-combine ko sila. So therefore, i-account mo yung bawat isang variance ng pinanggalingan accounted for dapat. So kung yung x1 ko galing dito sa population 1, x2 ko galing sa population 2, yung x3 ko galing sa iba pang grupo ng population, and so dapat na-account lahat yung variances na yun. Pero kung pare-pareho naman, galing siya sa isang, nag-sample out ka sa isang population lamang, then your new population mean now of your combined variable or your sampled population now, yung bagong population mo made of these samples, is just the summation now of kung ilang samples times your corresponding variance. So, kasi isa lang yung variance ng bawat isang x component mo. And then kung ilan siya, so that would be your Ito, i-illustrate natin sa 8.1 para clear. Okay. So, 8.1. Cans of beef stew. Meron siyang mu, 300 grams. Mean content of 300 grams. Standard deviation, sigma, 6 grams. Pero merong 24 cans in a case. So, bawat can, merong mu at sigma. So, ito yung mga yon. Itong mga x1 corresponding to x1, x2, up to xn. The n here is 24. Now, the mean content of a case then is therefore, yung bawat isa, ilan yung mean ng bawat isa? 300 times 24. So, ito yung nandito sa equation dito sa taas. Ilang x times that x bar ng x component. Okay? So, naging additive siya. So, yung bawat isa merong 300, pero 24 times yun. So, 24 times 300. So, ito na yung mean na content ng bawat case. Now, ano yung standard deviation of the contents of a case? So, it is now standard deviation of your W square. Standard deviation is, variance ang tinatanong muna. Variance to get the standard deviation. Anong tinatanong? Standard deviation, okay. So first, we get the variance. So this one in our equation 3. So the variance now, omega W square is equal to ilan? 36 times, ano ba? Nandito ako. Okay. 36, yun yung variance ko ng bawat isang x. And then, ilan siya? 24. So, 24 times 36. So, ang given kanina is standard deviation, and you know that variance is standard deviation square. Okay. So, now to get the standard deviation of your whole case, it's now square root of the variance of that content of the case. Okay, pinakita dito na additive yung variance natin. So yung individual variance ng bawat can doon sa 24 cans is yun yung total variance ng case mo. Similarly, ganun din yung mean. Yung mean mo is yung mean ng bawat isa times kung ilan. Okay. Variance of sample means. Kung maliit yung variance ng sample mean mo, x bar, x bar. Kung yung variance ng sample mean mo, sigma square, pero that is for population. Okay. S square. Okay. Variance of your sample mean, that is S square, ay maliit, then maganda siyang estimate ng population mean. Okay, this statement, iba yung ini-state niya talaga. Okay, let me say, kapag okay yung variance ng sample mean mo, it could indicate kung maganda yung pag-predict mo ng population mean or not. So, syempre, the better the variance, meaning mas maliit yung variance sigma square of your x mean, and then pwedeng okay yung estimation mo ng population mean. Alright, I'm dwelling so much. So, for a sample consisting of n independent observations, so meron kang sample, n, and if they are independent of each other, it means one is not affecting the behavior of the other one. And if it is randomly sampled, then yung probability ng bawat isa is 1 over n ng occurrence ng bawat isa. And so, ang definition natin noon ng mean is the summation of probability ng bawat isa times yung value ng outcome. And so doon actually nanggaling yung summation of x over n as the definition ng ating expression for mean. So x bar here is the summation of your x over the number of samples. So now we're expounding na ang reference dito is that they are randomly sampled and independent yung observations, yung n observations mo. So this is variance of a sample mean. So that's why it's sigma x bar square. X bar means that of a sample mean. Okay. So, like dun sa first kanina, yung sample population mo ngayon, or yung sampling population mo, yun na yung tawag natin dun sa nakuha mo from your original population. So now you have your sampling population. So pwedeng yung pinanggalingan nga niya is from different distributions, original populations. So may kanya-kanyang sigma yon, sigma 1, sigma 2, sigma n. And so yung contribution ng bawat isa is 1 over n. So yung bawat sample na nakuha mo man doon. And the constant kanina yun na A, B, C na A and B natin. So it's now 1 over n in your terms. And as we said kanina, kung galing naman pala sila, isa lang yung sigma, kasi galing sila sa same population, nagsample ka sa isang populasyon lamang, then it's simplified to this one. So now the variance of the sample mean, ito na yung sampling population mo. Nag-sample out ka and ito na yung variance nung nakuha mong mga samples. Okay? Based on your design, sampling design. So now it's the sigma of the original population over the n. Kung ilan lang yung isa-sample mo out doon. So for example, you have 20 items, kumuha ka lang ng 6 items doon. So maraming possible outcomes, right? Ng combination kung ilan, ano yung mapipili mong 6 doon. So your small n there is 6. And dahil maraming pwedeng outcomes doon sa 6 items na pwedeng makuha out of the 20 items, iba-iba, meron kang mean. Ano yung mean? That is the x bar. And ano yung variance ng sample mean ko? So, yun yung sinasolve dito. And itong equation 5 na to applies kapag independent yung n items na kinuha mo. So, meaning, hindi pwede dito yung yung conditional probability natin dati na kapag applicable siya kapag na meet yung first condition. It's not kasi random sampling as well as sampling is done with replacement. Meaning kung nung nag-sample out ka ng first item, nung magsasample out ka ng second item out of dun sa 5, pareho na ulit yung condition nung population mo. So, this one, again, equation 5, only applies for independent observations and for random sampling, and sampling is done with replacement. Ngayon, yung standard deviation could also be called standard error of the mean. So, sigma x bar. And note, na kapag tumataas dito sa equation 5, kung tumataas yung n mo, lumiliit yung variance. And therefore, yung standard deviation or standard error, yung sigma x bar squared or sigma x bar. And so, syempre, mas reliable yung technique mo, yung sampling technique mo, or kung ano man yung measurements na yun, na nakuha mo, mas reliable yung system na pinang-measure mo doon, or yung system na nagproproduce nung results na iyon. Okay. Kung maliit yung sigma, or maliit yung sigma square. So therefore, mas ideal kapag mas mataas yung sampling size. Of course, up to a certain extent na kaya ng oras, kaya ng pera kung sa sampling niyan. Kasi kung magsasample ka sa production, possible na destructive, masisira yung sample mo. Depende kung ano yung itetest mo dun sa sample. Okay. Ngayon, if sampling occurs without replacement, so kung nabawasan na ng isa, di nagbago na yung hindi mo na pinalitan ulit bago ka nag-sample out ulit. So, nagbago na yung situation ng population mo. And so, therefore, may correction factor dapat. So, we introduce here N, yun yung population size. Yung 20 kanina na items, that's the big N. Yung kukunin mo kung ilan out of it, tag-ilan, N small is 5. So again, when we say sigma x bar, it is now the variance of the mean of your sampling population. Yung sigma kanina originally, yun yung sa original population distribution mo. Okay po. Example, meron kang population, merong 259. So 3 items lang. Big N equals 3. Ngayon, samples of size 2. So, small n equals 2 kung applicable man yung big N natin dito sa calculation. Chosen randomly with replacement. Ibig sabihin, kung kukunin ko yung sigma x bar squared or sigma x bar, equation 5 po ang gagamitin. Verify equation 5 for this case. So sa equation 5, ang hinahanap is variance of equation ba? Of the sample mean. Variance of the sample mean. So, kung alam ko na yung sigma ng aking original population at alam ko yung sampling size which is 2, masosolve ko na. So, ano nga ba yung sigma square ng aking original population given ba? You can solve. Meron ka lang 259. So, mabilis mo lang naman makuha yung mean and pwede mong makuha yung kanyang sigma square. So, paano? Recall na ang mean is just the average. And then, yung variance, diba yung shortcut technique natin, you have the summation ng x square. So, therefore, 2 square plus 5 square plus 9 square. Minus square ng summation of x. So, ano yung summation of x? 2 plus 5 plus 9. And then, square mo. And then, over 3. Over n. So, square of your summation over n. And so, now, you have 8.22 as your sigma square. So, ito daw yung ipoprove mo na this 4.11 na nakuha natin using that generated correlation ay true for our system. So, ngayon, paano mo kukunin ngayon yung not using this equation, paano mo papalalabasin yung mean of your sampling the sampling mean, meaning yung tagdalawa na pwede mong makuha doon out of those 259. Ano yung mean ng lahat ng pwedeng outcomes na iyon? So, that is yung mean pala yung sinasabi ko. Ngayon, yung standard deviation naman is pwede mo ulit gamitin itong equation natin for variance na kung alam mo yung means ng bawat isa kasi ito dapat per sample kasi yung tagdalawa ma-express mo siya into one variable. So kung 2 and 5 yan, pwedeng 3.5. Kung 5 and 9 yan, pwedeng 7. So, para lang, bawat isa merong value. Okay. So, if we now use this to get the variance, so, alam mo na yung individual mean. So, and then, alam mo kung ilan yung, okay, let's just show here. Baka mas naguluhan pa kayo. So, first, ipakita lang natin visually yung distribution nitong original population. So, meron akong 2, 5, and 9. So, nandito siya. 2, 5, and 9. Since tatlo sila tag-isa, equal yung probability nila, which is 1 over n. What is your n? 3, right? 3 samples. So, 1/3. 0.33. And then, nung nag-sample out ka na, ilang possible combinations? 2 items ang kukunin mo. Okay, kapag ganon, we can say, meron akong isa, tapos pangalawa. If we use the multiplication rule in the counting techniques, so meron akong, sa first one, meron akong tatlong options. So yung first na mapipili ko is pwedeng 3 times. Yung second na item ko, since with replacement, ibig sabihin 259 ulit yung nandun. So ibig sabihin 3. Ibig sabihin, 3 times 3 equals 9. Ang pwede ko lahat na 2 items na makukuha doon. So, 9 samples. So, out of dun sa 9 samples, di ba? 2, 2, 2, 5, 2, 9, 5, 5, 5, 2, 5, 9, 9, 9, 9, 2, and 9, 9. Just to illustrate, ano yung probability? Alam mo na merong dalawang beses dito, yung 2, 5, and 5, 2, yung 5, 9, and 9, 5, 2, 9, and 9, 2. So, out of 9. So, 2 out of 9 at saka 1 out of 9 yung corresponding probabilities. So, they're just plotted here. Okay. So, again, ang hinahanap natin is sigma x bar square. And pinapalabas natin, isosolve natin, pinuprove natin yung correlation sa taas by solving from the actual samples na na outcomes from your sampling technique. Kuha ka lang ng 2 out of the 3. So now, your equation is again summation of the squares of your x. Ngayon, ano yung x ko na dito? My x now here pertains to the paired samples. Paired samples. So, since pair siya, pwede ko siyang ipakita, i-express in one number. Yung 22, 25, 29, paano? Yung mean lang nila. So, for 22, for example, edi 2 yung mean mo. For 25, so 7 over 2, 3.5. Itong 29, 11 over 2, 5.5. And so on and so forth. And so, for the first term now, it's the summation of your squares of your x, which are the means now here of your paired samples. And then, minus now your summation of x. So, lahat ng means, ang sum is 48. Siyempre, isosolve mo yan. So, the sum of the means of these paired items. Okay. So, that's 48 square over 9. So, here it's 9. Note that this is sigma of your sampling population. So your sampling population naman is 9. 9 lahat ng possible outcomes. So we use 9 here. Kanina dun sa population natin, original, 3 lang talaga yon 259. That's why we use 3. And it's the sigma of that whole population. Dito naman, sigma of your whole sampling population. Please don't get confused. Okay, that is why we use 9 here as your n. And have we proven it right? It's 4.11. If we just use the equation by just knowing kung ilan yung sampling size mo and the original sigma of your population, kung saan ka kumuha, yes, we can get. Na-prove natin. So we can use that one. Okay. Another example. Population of size 20. So big N mo is 20. Without replacement. So, kailangan may correction factor na tayo kung kukuha tayo ng sigma x bar squared or yung mean, yung sampling mean. So, the standard deviation of the population, sigma, 0.35. We require the standard error of the mean, so this is the sigma x bar, to be no more than 0.15. So, maximum na yung 0.15 na sigma x bar. So, what is the minimum sample size? Small n ang hinahanap. Given big N, sigma, and sigma x bar. Okay. So, we know na ang pwede nating gamiting relation yung may correction factor, which is this one, to get the sigma x bar. We are tasked to get the small n and everything else is known. And so, you will be able to get small n. So, minimum number of sampling size. Minimum sampling size is 4.5, 45. But you know, it should be integer pag nag-sample ka. So, syempre, kung 4 yan, ibig sabihin, hindi mo na-meet yung sigma x bar. So, dapat dun ka sa higher. Kasi di ba sabi natin, the higher the n, the more reliable is your sigma x bar. So kapag may ganito ka na compute, round up ka. Okay, 5 samples. Para yung standard error mo daw is no more than 0.15. So, itingnan natin kung tataas yung n mo, ay kapag diliit yung n mo, anong mangyayari? So, dito, kapag mas maliit yung n mo, ito mismo dito sa dito sa unang part ng term, kung maliit to, it varies, square root of n mo, yun yung manner ng okay. 1 over square root of n mo, yung manner ng pag-increase ng iyong sigma x bar. Okay. Kapag diliit ito, lalaki yung sigma x bar mo. So, kaya ang tanong is minimum sample size. Kasi kapag mas maliit pa dito, hindi na ma-meet yung standard error. Kapag standard error kasi gusto mo i-minimize, di ba? So, kung dapat, kapag nag-require ng standard error, hindi dapat yun ma-exceed. Kaya minimum sample size. Kapag mas mataas, mas safe ka. Okay. Okay, example 8.4. Standard deviation of measurements ng dimension ng isang mechanical part, 0.14 mm. So meron ka lang bina-measure, for example, yung bolt diameter. Ang standard deviation niya, kung ano man yung value, plus minus 0.14 millimeters. So, ano daw yung sample size? Small n. If the standard error of the mean must be no more than 0.04 millimeters and then 0.02 millimeters. So from our formula kanina na sigma x bar squared equals sigma squared over n, ang hinahanap mo dito is n, small n. And ang meron ka is standard deviation of all the measurements. So meron kang sigma. And meron namang bound na dito yung sigma x bar mo. So you will be able to get supposedly the sample size n. In the analysis, sinabi kasi na measurements of dimension of the bolt, for example, and measurement, so up to how many times mo ba siya pwedeng ma-measure? Marami. Could be infinite. Measure ka lang ng measure and then 0.14 millimeter ang iyong standard deviation. And dahil ganun yung parang continuous sampling lang siya, same at same naman yung bolt mo, di ba? I-measure mo. Tapos, okay, tapos na, measure mo ulit. Parang same, parang it's like random sampling with replacement. Meaning, applicable itong correlation at itong relation na to na sigma x bar equals sigma over square root of n. And so we just use that one. You will be able to get the n. So, yung implication ng n, it is the number of measurements to arrive to a measurement error of 0.14 dun sa iyong original. Well, given na yun dun sa population mo, but it should be the 0.04 millimeter size. Okay. Last example. Meron ka raw planta nagpo-produce ng steel rods. And so meron siyang merong planta na nagpo-produce ng something, pero meron siyang lagayan for steel rods, meron din siyang lagayan for bearings. So ito kasing rod and bearing, magka-pair to. Ito yung itsura niya dito sa here. So yung dulo nitong connecting rod mo is complementary siya sa size ng ka-pair niyang bearing. So yung diameter nila ay related. So yung rods mo daw, meron siyang mean, 7 millimeters diameter. Yung variance ng diameter niya is 0.1 millimeter square. Yung bearing naman, may mean siya 7.5 millimeter diameter. Yung variance ng mean diameter niya is 0.1 millimeter square. Ang tanong, what percentage of randomly selected rods and bearing will not fit together? So in the analysis, hindi sila mag-fit. Mag-fit sila kung yung difference ng diameters nila is positive number. Okay? Simplification na to, hindi kasama yung clearance mo. Yung actually clearance kapag mag-fit ka na together. Pero kung yung difference ng diameter nila ay yung diameter nila magkapareho or mas maliit yung difference magkapareho or negative, ibig sabihin it's not good as well. So kung magkapareho yan, that's 0, then hindi sila mag-fit. 0 yung difference ng diameter. Okay. This shows here on your right the rods and the bearings, yung diameter niya, and then the probability. So this is the probability distribution ng first and then the second population set. Okay. So if we let D, yung difference ng diameter nung rod at saka nung bearing, and so the mean difference now, originally meron kang 7.5 for the bearing, and yung rod mo is 7. So ang mean difference ng diameter is 0.5 millimeters. So kung sa mean yan, mas malaki yung diameter ng bearing. Well, originally, kung ganun yung situation, yung mean lang hindi okay. Kasi dapat yung bearing ay mas maliit yung diameter. So it means na lower than that, lower D values than that yung kasagot sa ating will fit together. So kung yung representative mean, it will not fit together. Yes, it will not fit together. So anyway, we're checking dun sa actual distribution. Okay. So sinabi naman na normally distributed yung both populations mo ng rods and bearing. So therefore, if we get a D na, yung certain D values ng combinations from rod and bearing, yung distribution nila is normal as well. Okay. So mean difference now is 7.5 minus 7, that is 0.5. So ano na yung variance ng differences? Sabi natin kanina, plus man or minus yung operation mo sa variance, itong linear combination of a variable, yung W kanina, yung variance niya manggagaling sa both components. So you have component 1, rod, and component 2, bearing. So therefore, additive. So 0.2 millimeter square ang kanyang sigma nitong combination na rod and bearing. And so now, this is normal distribution. And pwede nating gamitin yung sa table to get the cumulative probability kasi ang tinatanong naman will not fit together. Kailan sila will not fit together? Kapag 0 yung x or yung d value mo. So now you get the z value of that para yung cumulative probability up to a difference of 0. To note that in our population now here, in our combined population or the sampling population here na yung mag-fit or not, it's possible na mag-negative yung d values. That's why the cumulative probability here is from the negative d values up to mag-0 siya. So that is your x value or the d value. So 0 is your x, 1 minus 0.5 which is the mean of the d values over your sigma of your D sample. Okay. And so, if you now check your table again, the phi at that z value, yun yung cumulative probability up to yung difference now ay 0, up to finally mag-fit. At 0, hindi pa nag-fit. So, yun yung hindi nag-fit. Percentage ng hindi nag-fit. The cumulative probability from negative to 0, D. Okay. So now we get 0.13, 14, or 13% ang hindi mag-fit. Note, again, you can use your Excel, norms dist, close open parenthesis Z. Okay. Sige, stop tayo saglit before this final concept. So in sampling and combination variables, so we have shown lang how to get the new sigma of your sampling population or the new variance of your sampling population and the mean, and that yung variance is additive and also the mean. That is why yung example natin kanina na yung cans into case, so yung mean ng bawat isa doon, times kung ilan yung laman niya na 24, yun yung mean ng buong case. And yung variance ng bawat isa doon times kung ilan na items, yun yung variance nung case, yung case mo. It just indicates the additive characteristic of your mean and your sigma, your variance or your standard deviation. The more n, the better the more the sampling size, yung mean, di pala mean, yung sampling mean variance mo becomes lower at higher n. Similarly, iba yung masosolve mong, iba yung actual kapag actual mean, sample mean, sample variance, okay, kapag sampling with replacement and without replacement. Okay, so now, tapos daanan niyo ulit itong mga examples natin. So itong last example natin, ito yung may dalawang components. So it's now the W, the linear combination. That is why additive yung sigma square, yung variance nung isang component dun sa second component nung nag-combine ka na sa kanila. Kumuha ka ng D value. Sample with yung pairs na may D values. So kaya additive yung kanilang sigma dito. And yung mean as well, we said it's additive, and also if you subtract now, then you could also subtract the means. So yung mga napag-aralan sa from start, normal distribution, so it applies here. Z value for normal distributions. Okay, now finally, I will introduce the central limit theorem. Okay, in your sampling, the distribution of your sample means or yung sa characteristic ng sample population mo ngayon, it could approximate your normal distribution if random and independent sampling is done from a certain population na merong mu at sigma square na mean and variance. So, random independent sampling ang keywords. Now, if you're asked, how large does the sample size have to be para ma-achieve itong normal distribution approximation? Ang merong rough rule dito, sample size is at least 30. But of course, kung meron kang samples na may pinagkuhanan mo may mga outliers, possible na magkaroon ng problema, hindi siya mag-normally distributed. Okay. Itong last, basahin natin. It also gives some indication of which sets of measurements are likely to be closely approximated by normal distributions. if variation is caused by several small independent random sources of similar size, hindi yung kagayang outliers kanina, the measurements are likely close to a normal distribution. Kapag kasi meron kang outliers na makikita mong very large yung difference from each other, like nasa extremes sila, parang manifestation yun na meron kang sources of variation na malaki yung effect versus the others. Other sources of variation. And so, sinabi natin dun sa taas na kapag may outlier ay possible na hindi na siya normal distribution. Also, if one variable affects the probability distribution of the result, so like in terms of conditional probabilities, then hindi na siya nag-satisfy ng random sampling with replacement. Kasi without replacement nang nangyari. And then, so, merong deviation from normal distribution. And highlight if the most important single factor is far from being normally distributed. So, your corresponding resulting distribution now may not be close to normal. Okay. So, meron lang akong isa pang iniwan. So, siguro yung gist na lang niya yung i-discuss natin on Friday. And then, after this, parang dapat meron na kayong foundation dun sa mga na i-discuss natin for the how to design your experiment kung ilan man yung samples na kailangan para reliable siya. So, sampling size and I now know how to have a feel kung ano yung mga possible outcomes. So I can count I have counting techniques and I can now solve the probability. So I know the distribution. So ito yung possible outcomes. So dapat yung next nyo na is sa statistical inference na sa analysis and designing of experiment. Kaya ito sa inyo, kaya itong stat na to early on, kasi dapat magiging magandang basehan ninyo siya when you design experiments na for your thesis and of course in your other analysis applications for engineering analysis. Okay. So, yun lang for today and we will meet again on Friday. So, merong mga tanong.